Hi, I'm Phil, and today I'm going to have a look at the Microbit garden. And this is for a workshop during the school holidays for the Blacktown City Library. And it's going to be held at Lalor Park. So the workshop starts at 11 and finishes at 2 o'clock. And we're going to do two things. We're going to look at water control, have a break, then come back and have a look at light control. And it's all about photosynthesis. So we're going to take nutrients and minerals from the soil, and our plant is going to absorb them through the roots. It's also going to absorb water, and it gets carbon dioxide from the atmosphere, and it enters the pores in the leaf. And this whole process uses a special chemical called chlorophyll. Chlorophyll and sunlight, they produce the food that we need. So the glucose and the oxygen are converted by this equation. And this is what we're going to follow in this workshop. So we're just looking at the process there. We've got the sunlight with chlorophyll is making sugar. And we've got water going up from the roots all the way through the plant. And I'm going to use a mind map to navigate through the workshop. So it's going to start on the top right, move clockwise around, and we'll finish off with a review and some references. So the whole project is compatible with the Microsoft FarmBeats, well, as much as possible. The only thing is that we're actually going to use an analog light sensor, which is not yet calibrated, whereas the Microsoft FarmBeats uses a digital light meter, a much more sophisticated one, which breaks the light into infrared, visible, and ultraviolet. But everything else is similar. And we've actually added a 4-digit LED display to give us some local feedback. And we're using every hub and every port on the Microbit computer. And we're going to use a M5 stack watering unit, which has both a sensor for soil moisture and also a pump. So let's have a look at the hardware. We'll be looking at using a Windows PC, a Microbit computer. We'll be using Grove electronics, and that comes from both Seed Studio and M5 stack. We've got plant lights. We've got water components like water tanks, pipes. We've got electrical power, and we've even got some trees to play with. Okay, so if you haven't used the Microbit before, here's a chance to have a quick look. So on each side, there are special functions. On the front, there are two buttons. There's button A and B. And in the middle of the buttons, there's a LED array. And since you're using version 2, you'll be able to use the logo touch button on top. So you can see there's quite a lot of peripherals already attached. If you include the sensors on board, like the accelerometer, the magnetometer, the temperature, the light, you can do a lot with the Microbit computer. And a little bit more detail about how much memory it has. It's also got a radio, and the version you're using has a microphone and a speaker. So let's just have another look at all those. So we've got the push button A, we've got push button B, we've got the USB connector, and that connects via a USB cable to your Windows PC computer. It also provides power, but there's not enough power for all of the projects we'll be working on, and we need to add an additional USB cable to the interface board called BitMaker. We've got an edge connector, and that's where the BitMaker board connects. And we've got the logo button, which you can use as an additional button for switching functions on your project. And we're going to use Makecode from Microsoft. And the version we're using is for Microbit. So the different panels, we've got the simulator on the left. We've got the data panel, the toolbox, a work area, a menu, and the download area. So let's have a look at some of these. We've got the menu. The menu is right on the top there. And we've got the simulator, which can simulate the functions of the Microbit. And if you use that effectively, you can speed up your software development so that you don't have to download the program into the Microbit for every small change you make. You can do a lot of testing using the simulator. An important area is the toolbox. And this is where we grab the commands or statements and create our program. And we make up the program in the canvas or the editor. And we've got one other feature, which is the toolbar. And this is where we can do two things. We can download the program, and we can also connect via the USB using web USB to communicate with our Microbit. And we've got an extended area, an extended work area. So if you want to extend it, just press that button and it gets rid of the simulator. So the extended work area is an important area where we build up our program. And the Makecode will mainly use some simple, but there will be some advanced features that we will use, both functions, pins, how we can access the pins on the Microbit, and we'll be using extensions. So these bring in additional commands, like commands for Grove and a software real-time clock. So here are the projects we'll be working on. We'll be working on water projects and light projects. And there'll be some demonstrations that you can have a look at. So here are some of the demos. We've got the Microbit garden, we've got air quality, and we're going to look at some robust sensors. So here's one of the demonstrations, and it's monitoring and measuring carbon dioxide. So you can have a look at this one where we're not only measuring carbon dioxide, but we're also measuring the temperature and the humidity. And you can have a look to see how this works. Another one is air quality, where we're measuring carbon monoxide this time, alcohol, and other aromas that are in the air. And there's an important one which measures the dust from bushfires or from car exhausts. And if there's too much of this, it can cause irritation to your eyes, nose, throat, and so on. And it can cause long-term health effects. So have a look at that one. It is able to measure the amount of dust. And that's a demo. We won't actually do that as a project. And another one is we're using the M5 Stack Mini encoder, and it's going to set the switch points or the set points for both water and light. Okay, so let's have a look at the watering project. This is quite a simple one. And what we're going to do is just some manual control of our pump. So when we press button B, we're just going to toggle between stop and start. And we're also going to add an additional safety feature where the logo button can be used to disable the pump just by pressing it. Okay, so one of our objectives is to learn how to use the BitMaker with connecting to Grove modules. And we're going to learn how to connect to the Windows PC and get Makecode up and running so we can do some software coding. Okay, in that coding, we've got some of learning objectives. We're going to learn about variables and functions. We'll look at modular programming, and we'll use functions for achieving that. We'll look at how to use logic, like true and false, and we'll learn how to connect to hardware. Initially, we'll only do the reading or the writing to digital ports, so we can read or we can turn on some hardware. And we'll have a look at event programming, incremental programming, and lastly, we'll have a look at saving our program on a USB stick. Okay, so what we're after is designing a program which allows us to do simple pump control. And when we press button B, we toggle from on and off. And we can also use a combination of button A and button B to do some manual pump control. And one of our design issues is to make sure that the current limits are not exceeded in the Microbit computer. So that's one of the issues. Microbit can only put out a maximum of 110 milliamps for version 2, and we're going to increase that limit by using initially BitMaker, and in project 2 we increase that current limit by using a relay. Okay, so safety first. We're mixing both water and electronics, so we need to make sure our water pipes are tied down, and we're going to use some pegs to do that, and plenty of paper towels on hand ready to clean up the mess if we do spill. Okay, for hardware on this project, we're going to use Microbit, and it'll be version 2, but it'll still work with version 1. From M5 Stack, we're going to use a watering unit, which is Grove compatible, and it connects to the Seed Studio BitMaker. And not only are we going to use a standard cable, but we'll use an extra long cable if our computer is a fair distance away from the plant we want to water. Okay, so we need a Windows PC and 2 USB cables and a memory stick, and desirably a safety switch where we can also turn off all the power to the Microbit if we have a problem. Okay, so we've looked at some of the water management issues and safety, and let's see how we connect it all. Microbit's connected by one USB cable. The other one is connected to BitMaker. So we also have to make sure that the power on the BitMaker board is on. So the first thing is to get used to BitMaker and identify where all the ports are. So on the top right, we've got P0, and that's port 0. But there's actually, on that Grove connector, both port 0 and port 1. And port 1 is duplicated on the next port down. And the last one is port 2, and that shares with port 2, and it's the top wire. The next wire down, which is the white wire, the top wire is yellow, the next one is white, and then we have power and ground. So have a look at your Grove cable, and you'll see it's color-coded. And there's only one way you can put that Grove cable into the Grove socket, but the yellow goes to the top, and the bottom one, the ground one, is black, and that helps us connect our peripherals to the BitMaker, and BitMaker then sends those signals and gets the power, some of its power, from the Microbit computer. And in this project, we're going to connect using a Grove cable the M5 watering unit, which has both a pump, which is an actuator, and that's going to be connected to port 12. And we'll be using the port 2 to measure the moisture in the soil. Okay, so here's our software, and you'll notice that we're starting on the left with an on-start block, and each of these blocks are like envelopes that contain a sequence of statements or commands. There's nothing in the forever, but the event program is that if you press button A or B, you can see that there's a block associated with that. So nothing's happening with button A, so it's not represented, but button B is used to stop the pump. And we set a flag there called a variable called the pump stop. So right at the beginning, we need to set up some variables. One's going to be called pump stop, and the other one is called the pump test. And we're duplicating that with the logo. So pressing button B or pressing the logo do the same thing. And we're using button A and B just to test the pump. And here we're toggling it. So we can go from a pump on or a pump stop. And they're represented by functions on the right. So you can see that we're controlling pin 12. When it's a 1, it shows that there's a P on the Microbit LED array, and that means the pump's on. Or alternatively, we can set the bit 12 to a 0, and that will show an S for stop on the Microbit array. Okay, so in the forever, we've gone through that. There's some more detail for the extra functions. And how do you get the pin control? Well, you need to go down to the advanced area and pick the pins and drag the digital right and select pin 12 in our commands. Now, once you've assembled all that, you download it and test your program. Good idea to also store it on a USB drive so you can come back and upgrade it if you want to later on. Okay, so we've called this particular program timer 4A. So give your program a unique name, and that name will become the file name on your USB drive. Then you can download it. So once you've done it all, you've downloaded it, you then physically test it and find out whether it meets the requirements. And here it's quite simple. We're just doing manual control. That is pressing button B to start the pump, or pressing it again to stop the pump. So what you need to do is just check that it actually works. And did you learn some extra coding? And what were the extra commands that you used? Okay, for project 2, we're just going to go a little bit further and use the soil moisture sensor. So we'll build on top of what we've done already, and we're going to use a concept called set point. And it actually looks at the dryness or the moisture in the soil. Coding-wise, very similar, but we're going to add a couple of extra features. We're going to look at a bar graph and plot that on the Microbit LED array. And we're also going to map the variables to variables that we're more familiar with, like soil dryness rather than wetness. module. We're going to look at incremental programming. That is, we can do it a stage at a time. So this is like stage 2, where we're building up the program. And later we'll be using a 4-digit LED display, which is something extra that we put on. And for soil moisture, we're going to map the dryness measurements to wet values. And that's where that mapping function comes in. Safety-wise, as we spoke about before, we just make sure that we're using low voltage DC and that we've got our water well contained. And the design is very similar to what we did before. Hardware-wise, we use the same components, and we're also careful about the water management. So it's the same arrangement that we had before. This time the program is a little bit more complicated, and you can see right on the start area, we've set our program name, and we've got more commands this time, or more variables this time, and they're all associated with the moisture. So the first one is the moisture set point, and the maximum one we'll be dealing with is 70. So if we've got a very dry plant that might go in the desert, we might actually go towards that level. That is the maximum level. Then we've got the minimum level of for set point. So a plant that is not so thirsty can actually be set near the minimum level. And we can put our set point anywhere in between. And we do that by pressing button A. So it's going to increment the set point with an increment value, and that will be added on. So the other variables are the same ones that we had before. And we're going to use, now you can actually see a mistake in that program. It actually hasn't set the moisture increment. So we need to actually put that in on our list of variables to initialize. So we've added a couple of extra functions here. One is checking the water and also getting the data. And when we get the data, we do our mapping function, because the value that we get is the value of the analog to digital converter. And we're going to map that between 100 and 0, so that we're measuring true moisture. Okay, so a little bit more detail about setting those variables, and we also need to add the increment to that. Now, a little bit about set point. Set point is where we have got a target for our water. So we want to look at our particular plant, and if our plant is a thirsty plant, we'll actually have a low moisture level or a high moisture level that we want to set. So while we're measuring soil moisture, we want to make sure that we feed the information back with a feedback path, and that helps us keep the whole thing stable. Okay, so our program in the forever and the time, we're going to actually use a timing function, and every 1 second we're going to call get data and check water. When we press button A, we increment the moisture value, and if it's at the maximum, we reset it to the minimum, and we show what that is on the LED, the Microbit LED array. Pump B is what we used it before, so we just use it for stopping the pump. And button A and B is a pump test. And the logo button just repeats what we did with button B. So a little bit more detail about the functions of getting the data and checking the water. And our results, here's our final, after we've downloaded the program to our Microbit, we check it and make sure that it works according to the requirements. So our manual control should still work, and we should be able to get the pump working when the soil is at the right point. Okay, we can also monitor the results using the Makecode monitor. So if you show the simulator panel on the web monitor, you'll be able to see these graphs on your computer. Now, finally, this project just adds a weather station and a 4-digit display to our water control. And I won't go through all the details, but all we're doing is just building on what we've already done here. And the coding, we're using an additional extension to support the 4-digit LED display. So now we've got some extra things to work with, which is the extra visual cue and we've got the 4-digit display to show us what the parameters are. Safety-wise, same as before. Hardware-wise, we're adding the Grove 4-digit display and also the Grove BME280, which can measure temperature in the air humidity, and also the pressure in the air. And to do that, we need 3 Grove cables. Okay, so the design not only includes a manual control, but the automatic control with feedback for the pump with measurements from the soil. And we're going to send the data back to the PC, and we're going to set up a communications protocol in this format so that Microsoft Excel can actually analyze the data a bit further. And we can do that not only for analyzing the data that we collect, but we can also use it as a debugging aid to help us find out if there are any problems with our program. Okay, so our extra hardware is similar to what we had before, and the water management is similar. So here's the extra bits are added on the left. So in the middle there, on the left, we've got the I to C, and that's where we add the weather unit. The BME280 sensor is added. And just above that, on port 8, we add the 4-digit display. And what we'll do is just have a look at the code. So it's similar to what we did before, so you'll recognize some of the functions, but we've added a little bit more this time to the get data. So not only are we reading the analog port on P2 for soil moisture and remapping that, but we're also getting the BME temperature, humidity, and pressure. And we've added an additional function that allows us to transmit all of that data to the Windows PC. And it allows us to show the soil moisture on our 4-digit display. Now, what's interesting, on the 4-digit display, we're showing soil moisture and moisture set point all at the same time. So on the 4-digit display, we get the soil moisture as a measurement, and on the right, we get the set point. Okay, so our next video will all be about plant lighting. But stay tuned, and we'll have a look at some live demonstrations on constructing the water control with our BitMaker and Microbit. And our next video will look at plant lighting. So that's all from now. Hi. For project number 1, we're going to use the Microbit to do manual pump control using the push buttons on the Microbit. So I've previously filled my water tank with water and I've marked off 100mm increments so we can see how much water has been consumed, not only by the plant, but also from the evaporation of water from the soil. And this is my calibration of 100 mils. And what's going to happen is that the water is going to be pumped from this water tank to this other tank over here, which has got the water unit from M5 Stack. And on the bottom, we've got that soil moisture sensor. And on the top, we've got a pump. And it's connected to pipes. So the pipe that's going into the dry tank at the moment is going to be fed from this water pipe over from the water tank. I've already downloaded the software, and all I have to do to turn on the pump is just simply press button A and B together. So P for pump, and you can see that the water is currently going into the dry tank that's going in at the moment. A little bit slowly, and what's happening, we've consumed now about 100 mil of water already. And if we want to stop it, we just simply press either button B, or we could press the logo button. And to resume testing, we just press button A and B together. So the pump is back on again. So we can see that that water consumption is going down, and we're around about 100. We've pumped about 150 mil at the moment. So that's the simplest experiment. And if we want to also stop it, we can just press the logo, which is stop the pump. In project 2, we again use the Microbit on a bit maker connected to the watering unit. So the watering unit's over here. Now this time we're going to use the soil moisture sensor. And the way it's set up is that when I take it out and provide a dry condition, the water will be pumped. So it's now pumping the water, and you can see the water level going up gradually. So if I put it back in again, it will stop the pump because the soil represented by this other tank is already wet. And the tank, we're gradually filling up the tank with water. And if we want to change the set point, we can increase the set point by pressing button A. So you can see the set point at the moment. It can be higher. The problem with this program is we're not quite sure what the set point is. And that'll be overcome by the next project. This is project 3. And again, we have Microbit sitting on top of BitMaker, but this time we've added 2 additional Grove units. The first one is a BME280, and it's going to measure the air parameters of temperature, humidity, and pressure. And next to that, there's the 4-digit display. Now, this has been set up so on the left, you can see the measured soil moisture, which is 50 at the moment. And on the right, there's the set point. So if the value is less than the set point, it will turn on the pump. And the pump is connected via this long cable to a water unit over here. And there's a water tank, and it's going to take water from the water tank into this other tank. Normally this would be the actual soil and the plant would be in here, and the soil moisture would be right next to the plant. So at the moment I've got the pump off, but if I turn everything on, you'll see that the pump's on. And it's gradually, slowly filling with water at the moment. So quite slow. And we can increase the set point by pressing button A. So the set point is now 66. So if we can get it right down, it'd be good to see that set point. So the set point's actually now lower, and the pump has now stopped because the soil moisture is much less than the set point. But we can take the soil moisture sensor out, and you can see that we're now running the pump. That's because you can see the measured value of soil moisture is only 47. And if we put it back in, it will be 57, and the pump will stop. And that concludes our projects on soil moisture measurement and water control.